Good day. So today we're gonna talk about compound interest. Before starting this lesson, let's review the different formula in getting the different components of the compound interest. Okay, so first we have F equals P times the quantity 1 plus R raised to T. We use this formula if our compounding period is annual. That means that the interest will be paid after uh, a year. No? So the interest is paid yearly. Then we have uh, F equals P times the quantity 1 plus R over M raised to MT. Okay, so where P is the principal, R is the rate, and M is the compounding period. No? And T is the time. Okay, so this formula is used when the compounding period is more than once a year. Example, if the interest is compounded monthly, uh, this means that the interest will be paid every month. Okay, so later on we will tackle it. Then another formula is I sub C equals F minus P. So we simply subtract, in order to get the interest, we simply subtract the future value and the principal value. Okay, so we use this formula when we look for the compound interest. um, mhm. While this formula above, we use this when we are looking for the future value and the compounding period is more than once a year. Future value or the maturity value. Here we use this when our compounding period is annual. Okay, so while this formula below, P equals F over the quantity 1 plus R over M, close parenthesis raised to MT. So this formula is used when we are looking for the principal amount, the money invested or the money borrowed in a compound interest environment. Okay, so let's discuss first about the compounding period or the M. Okay, so if our problem says that compounded monthly, so that means our M is equal to 12. If our problem says compounded quarterly, that means our M is equal to 4, or it means that in 1 year the interest will be paid 4 times. Okay, then if we have semi-annually, so our M, the value of our M is 2. And if we say compounded annually, so our M is equal to 1. Okay, so let's try some examples. Okay, so Hasmin borrowed money from a bank at the rate of 1.89% compounded semi-annually. If the amount she borrowed is 13,000, how much interest will she need to pay at the end of 6 years? Okay, so here we need to find what we are looking. Okay, so if we read it, so we are looking for the interest. Okay, and in order to find the interest, we need the formula I sub c is equal to future value minus principal. And here we have 13,000, and it says that the 13,000 is the amount she borrowed. That means that 13,000 is our principal. Okay, and uh, the 1.89% is the rate, or in decimal form, no, we just divide it by 100, so it is 0.0189. And our compounding period is semi-annually. That means our M is equal to 2. The time is she need to pay at the end of 6 years. That means our T is 6. Okay. Okay, so we already have the P. To find the interest, we need the future value. So the formula for future value is F equals P times the quantity 1 plus R over M raised to MT. Okay, all we need to do is substitute the values. So P becomes 13,000. Copy the parentheses, copy the 1 plus instead of writing percent, we just write the decimal form. So our R is 0.0189 over our M is 2. Okay, then our M again is 2 times 6. Okay, so here we need to apply the PEMDAS, no? So first we do the operations inside the parentheses. So we have 13,000. Copy the 1. Then let's divide first. So 0.0189 divided by 2 is 0.00945. Okay, then 2 times 6 is 12. Again, apply the PEMDAS or the parentheses first. So we have 13,000. We need to add this. So we have 1.00945 raised to 12. Okay. So the PEMDAS rule stands for parentheses, exponents, multiplication and division, and addition or subtraction. So after the parentheses, we need to do the exponent. Okay, so we just first raise this value to 12. After that, we multiply, and the result is okay. The result is F equals 14,553.29. So this is our future value, or the money that she need to pay at the end of 6 years. But the question here is we are looking for the interest. So now that we have already the value for F, so we simply use the formula I sub C equals F minus P. Our F is 14,553.29 minus the P is 13,000. So the interest or the compound interest is 1,553.29. So this is our answer. Another example, if P is equal to 20,500, R equals 2% and compounded annually for 3 years, find the compound interest and the future value. Okay, so again, all we need to do is substitute these values to the formula. So our formula for future value is F equals P times the quantity 1 plus R over M raised to MT. Okay, so as you can read here, the compounding period is annually. So instead of writing this formula or using this formula, we go to the formula F equals P times 1 times the quantity 1 plus R raised to T. Okay, so we use this formula because the interest will be paid after annually, no? So we substitute. So P is 20,500. Copy the 1. The hour rate is 2%, and to convert this into decimal, we divide it by 100, so it becomes 0.02, and our time is 3. Then apply the PEMDAS rule. We have 20,500. 1 plus 0.02 is 1.02 raised to 3. Again, after the parentheses, we need to do the exponent. Okay, so if we do that, we will have 20,500 times 1.06 1208. After that, we simply multiply and it will become 21,754.76. So this is the future value. And after finding the future value, we can now find the compound interest. No? So I sub C is equal to F minus P, where F is 21,754.76 minus 20,500. It will become 1,254.76. Okay, so that means that the compound interest for 20,500 with 2% interest rate compounded annually for 3 years is 1,254.76. Let's have another example. Arthur wants to set aside an amount to be invested in a fund earning 1.02% compounded quarterly. If he wants to accumulate 250,000 in 4 years, how much must he set aside? So if you can understand this problem, what we are looking here is how much must he set aside, or the principal, in order to have a future value of 250,000 in 4 years. Okay, so the formula for the principal is P equals F over 1 plus R over M raised to MT. Okay, but before we delve in the formula, let's define first the given values. So 250,000 is actually the future value, and the 1.02% is actually our rate. Okay, so we need to rewrite this into decimal form. So we just divide by 100, so we have 0.0102. And our M, so if you can read here, it is said that compounded quarterly. So that means our M is 4. And our time is 4 years. Okay, so now we can continue to solve this. So all we need to do is substitute the values. So F is 250,000 Copy the 1 plus 0.0102 over 4 raised to 4 times 4. Okay. And after that, we first apply the operation. First, use the operations inside the parentheses. So divide first, then add. No, you need to divide this before adding. So it will result to 250,000 over. So you have 1.00255. So 4 times 4 is 16. Okay. So after this, you need to apply the exponent before dividing. So we have 240,017.74. So this is the money he must set aside in order to have a future value of 250,000 in 4 years. Okay. So if you have queries, just message me. Thank you for watching.